So here we have an inclined plane which is connected with a pulley, and there are two blocks which are connected with strings, and the two strings are going over the pulley. So first it is mentioned that the inclined plane does not have any friction. The plane is at an angle of theta above the horizontal. This string which is connected to block M1 is wound around a frictionless pulley, which and the radius of the pulley is given as R. And now there is a second pulley which is connected with mass M2, and the radius of that pulley is 2R. So double the radius of the original pulley. Now this entire system is in equilibrium as the question has mentioned. We need to figure out the ratio of M1 by M2. Now the question has specified equilibrium, which means we can say the system is in linear equilibrium as well as rotational equilibrium, which means we need to balance the forces as well as we need to balance the torques. So we will start with step number one, which is to draw the free body diagram of every object in the system. So we have three objects here, M1, M2, and the pulley. Starting with M2, so the first force acting on M2 will be the weight of M2, which is M2G acting downwards. And then we will have tension acting along the string, and let's call this tension as T2. Now coming to M1, the different forces acting are M1G, which is the weight of the object acting downwards. Then we have the tension acting along the string away from the object. Let's call that as T1. And since M1 is in contact with the surface, it is going to have a normal reaction going this way, perpendicular to the inclined plane. And since the inclined plane does not have any friction, so there will be no friction acting on the block. Now coming to the pulley, let us show the directions of tensions acting on the pulley. For the pulley, let me draw a clear separate diagram. Consider this is the zoomed in view of the pulley. So consider this is the second string which was connected with M2. This is connected with the second bigger pulley. So the direction of tension, remember, is always away from the pulley going along the string. So this arrow will be T2. Similarly, we have another string connected with the first pulley. So let us draw the direction of that tension. This will be away from the first pulley acting along the string, and this will be T1. And apart from this, of course, there are other forces acting on the pulley. For example, there will be the weight of the pulley acting downwards. And also, since the pulley is connected with this support, so there will be some sort of contact force which is coming from the support system. But we will be ignoring the W and F force. Why is that? Because the torque due to W and the torque due to this F will become zero. Let me write it down first. So torque due to W and the torque due to F will be equal to zero. And why we are considering as zero? Because when we will be finding the torques we will be finding with respect to the center of the pulley. And since the weight of the pulley and this force F both are passing through the center, that's why the both torques are considered as zero. So we will be only interested in figuring out the torques due to T1 and T2. So we will be doing that later. All right, so we have drawn the free body diagrams of all the objects. That was step number one. Step number two is to balance the forces, which is linear equilibrium. F net should be equal to zero. So let's start with M2. There are only two forces acting on M2, T2 and M2G. So let's equate them. T2 will be equal to M2G. Now coming to M1, there are three forces acting N, T1 and M1G. So M1G can be broken down into two components. So one component of M1G will go along the incline. So this will be M1G into sine theta. And another component of M1G will be going perpendicular to the incline, which is M1G cos theta. Now, since the block is in equilibrium, forces needs to be balanced out. So N will be equal to M1G cos theta, and the value of tension T1 will be equal to M1G sin theta. So let me write T1 will be equal to M1G sin theta. So these are the two equations we get using the linear equilibrium. Now step 3, rotational equilibrium. The net torque acting on the pulley should be zero. Earlier, we discussed only T1 and T2 will contribute to a non-zero torque. So let's write down the formula first. Torque, the general torque formula is Rf sine theta. Let us start with T1. So let me write torque due to T1. So the magnitude of the force is T1 multiplied by, we need the value of R. And in this case, R will be the distance between the center of the pulley and T1. So this particular length about which my cursor is hovering, this is the radius of the first pulley. And let's see, is the radius of the first pulley given in the question? It is. It is mentioned that the radius is R for the first pulley. So let's write down the torque due to T1 will be T1 into R multiplied by sine 90, which is 1. Hence, the torque due to T1 will be equal to T1 multiplied by R. And let's figure out the direction of this torque. So T1 has the tendency of rotating the pulley in an anti-clockwise fashion. So this torque will be anti-clockwise. Now let us figure out the torque due to the other force T2. Magnitude of force is T2 and the value of R will be the radius of the bigger pulley, which is double, which is 2R. So the torque due to T2 will be T2 multiplied by 2R, and the direction of torque T2 will be clockwise. So let's write down the torque due to T2 will be clockwise in nature. Now, since the pulley is in rotational equilibrium, total anti-clockwise torques should be equal to the total clockwise torque. So these two torques are supposed to be equal to each other. So let's equate these two expressions. So we will get T1R equals to T2 multiplied by 2R. R will get cancelled out and we get the expression as T1 is equal to 2 times T2. And now let's go back to the question in order to check what are we supposed to find. We have to figure out the ratio m1 upon m2. Earlier we had figured out T1 was mg sine theta and T2 is mg. So let's put that in this expression. T1 is 2 times T2. So T1 is m1 g sine theta. So in place of T1, we will write m1 g sine theta, and this will be equal to 2 times T2, which is m2 into g. Now, in this case, g will be cancelled on both sides. And now, since we have to find m1 upon m2, let's try to make that as the subject. So we will get 2 in the numerator and sine theta in the denominator. So m1 upon m2 will come out as 2 upon sine theta, which is in option B. And that's why B is the correct option for this question.